Welcome to the course on environmental engineering. Water supply system, the complete layout from the surface, from the source to supply to the distribution. Source of water, aquifer, previous pervious strata, layer, aquiclude, impervious strata, surface source, the source in which the water flows from Earth's surface, that is the rivers, lakes, stream, natural ponds, impounded and surface storage reservoirs. Surface water have suspended impurities major, hence not considered safe for water supply without necessary treatment. Subsurface source, groundwater source which supplies water from below the earth's surface, that is spring, infiltration gallery, wells and porous pipe galleries, which is pure and but may have some hardness. Springs, natural outflow, underground passage of water finally reaches to the earth's surface is called spring. Surface spring. It forms due to the aquifer is exposed to the valley against the vertical cut is shown in the figure. Shallow spring. The water collects by forming reservoirs. Water table, reservoir, artesian or deep state sea springs or deep sea springs. Water flows out automatically, although two impervious strata shown in the figure. Infiltration gallery, the horizontal tunnel constructed at the shallow depth along the banks of the river to intercept the groundwater level. These are most useful in dry season. The quantity of water available for these depends upon yield source, rate of water percolate, nature of soil, size of gallery. Infiltration gallery, river, quality of water per capita demand, quantity of water required per person per area per day throughout the year in the city town per liter per capita per day LCPD abbreviated. Per capita demand, total yearly water requirement of the city in liters upon 365 into design population is equals to 270 LCPD for Indian city. According to IS 1172 1963, water consumption under normal condition, domestic supply 135 LCPD 50%, homes, hostels, school, etc. Industrial purpose 50 LCPD 25%, demand for public use 10 LCPD 5%, fire demand and commercial institutional 20 LCPD, losses in water losses in waste and theft 55 LCPD 270 LCPD. Variation in demand, maximum daily consumption 1.8 times average daily demand, maximum hourly consumption 1.5 times average hourly demand. Fire demand, National Board of Fire Ritter's formula, Q is 4637 under root P times 1 minus 0.01 under root P, where P is the population in thousand, Q is the liter per minute. Fireman formula 1135 times P upon 5 plus 10. Kuchling formula Q equals 3182 under root P. Boston's formula Q is equals to 5663 under root P. Bruton's formula Q equals 900 under root P. Population forecasting methods. Arithmetic increase method. For old cities, Pn is P0 plus Nx bar, where Pn is the population after n decades from the present. P0 is the population in present, that is the last known census. N is the number of decades from Pn to P0, that is Therefore, n is equals to yn minus y naught upon 10. One decade is 10 years. X bar is the average population increase per decade. Population of last minus population of first upon number of decades from last to first. Geometric increase method. New fast grown growth cities. Pn is P naught 1 plus R upon 100 to the power n, where R is the average growth rate percent. Incremental increase method. Any type of city. Pn is P naught plus nx bar plus n into n plus 1 upon 2 y bar, where y bar is average incremental increase PL minus PF minus PL minus PF upon number of decades minus 1. Example, 42,000 plus 25,000 minus 34,000 plus 28,000 minus 4 minus 1 is 5,000 upon 3 is 1,667. Impurities of water. Suspended impurities. These are almost visible, may settle down after long time, causes turbidity. These can also be removed by filtration and sedimentation. Example, slate, clay, organic, inorganic, bacterial, plants, algae, fungi, protozoa, etc. Second, colloidal impurities. These are not visible to naked eye, but color of water changes, cannot easily be removed by ordinary filters. They can be removed by coagulation. The bacteria are growth and healthy easily by using colloidal impurities, which makes epidemic fast spread disease. Dissolved impurities. These are chemically reacts with water, salt. Major of these causes hardness. Some of these may remove hardness, that is softness. Since majority of these comes from suspended and colloidal impurities, dissolved impurities. Now second is metals. Iron, red color. Manganese provides a brown color. Lead of arsenic is poisoning. Gaseous. Oxygen corrodes metal. Chlorine, Cl2 plus ammonia, NH3, bad taste. Carbon dioxide and hydrogen sulfide, H2SO4, acidity. Living organisms in water. Living organisms in water are bacteria, algae, protozoa, etc. Bacteria, pathogenic bacteria, harmful or disease causing bacteria, non-pathogenic bacteria, useful bacteria. Aerobic bacteria, bacteria required oxygen for living. Anaerobic bacteria, floculative bacteria, bacteria can live without oxygen. Bacteria can live with or without oxygen. Name, shape of bacteria: cosy, sphere, bacilli, rod. Sprilla, twisted rod. Algae, relates to planktons responsible for taste and odor. Protozoa, all unicellular animals are called protozoa. Physical examination of water. Temperature test, thermometer, helps in the determining the density, viscosity, surface tension of water. Color test, platinum cobalt scale. Turbidity test, silica scale. It is measure of passage of light through the water. Water is said to be turbid when it contains visible matter in suspension. Turbidity may be determined by turbidity content in ppm. Bayes turbidity meters, less than 50 parts per million. Jackson turbidity meters, greater than 50 parts per million. Taste and odor test. Osmoscope. Water odor is tested at 20 to 25 degrees centigrade. Odor is based on PO value. PO value 0 meaning no. PO value 1 very faint, 2 faint, 3 distinct, 4 strong, 5 very strong. Chemical examination of water. Total solids. Suspended solid plus colloidal solid plus dissolved solid is total solid. Weight is taken after evaporation of water. pH value of water potentiometer. pH equals negative log of H plus ion concentration is equals to log of 1 upon H plus ion concentration. That is pH is directly proportional to 1 upon H plus, that is H plus mm, increases pH decreases acidic, H plus decreases pH increases alkaline, and H plus OH minus equals concentration of H plus and OH minus equals 10 to the power minus 14. Negative log of H plus and OH minus is equals to 14. Negative log of H plus minus negative log of OH minus is 14. pH plus POH is 14. pH less than 7 is acidic, pH greater than 7 is alkaline. Permissible limits. Physical temperature 10 to 15 degrees centigrade. Color 10 to 20 parts per million. Turbidity 5 to 10 parts per million. Chemical pH value 6.5 to 8. Total solids 500 parts per million. Chlorides 220 to 50 parts per million. Chloride to 50 parts per million. Hardness 100 parts per million. Copper 3 parts per million. Fluorine 1.5 parts per million. Iron 0.3 parts per million. Iron and manganese 0.3 parts per million. Arsenic and lead 0.05 parts per million. Chlorine 0.1 to 0.2 parts per million. Water treatment. Screening process of removing large sized particles, example leaves, bushes, branches, debris, etc. Filters by screen of angle 45 degree 60 degree to the horizontal to increase the area and reduce velocity. Velocity of flow is greater than not velocity of flow should not be greater than 0.75 meter to 1 meter per second. In screening, sedimentation. Particles settle down as a result of action of gravity and force, settlement of particles and temperature. Design of sedimentation tank. Flow velocity, discharge of water entering the basin. Vertical cross-section area of tank equals Q upon VH. Flow velocity is 30 cm per minute or 5 mm per second. Overflow velocity 600 liter per hour per meter square or surface loading is discharge of water entering the basin upon the plan or surface area of the tank equals Q upon BL. Detention time. Time required to fill the tank at a given rate of flow is detention time. It is 5 to 8 hours equals volume of tank upon discharge of water entering the basin. BLH upon Q. Dimensions. Depth is 3 to 5 meter, width is 10 to 12 meter, length is not greater than 4 times the width. When coagulants are used, efficiency is almost double. Rate of settling of particles in water depends upon viscosity of water, density of water, specific gravity of particle, and shape and size of the particles. Sedimentation added with coagulation. Certain chemical compounds called coagulants are added to water. They absorb colloidal impurities and form flocculant like gel participates participate called flocks. These flocks are settled down due to the gravity. Coagulation is necessary when turbidity is greater than 4.45 parts per million. Important coagulants. Almost all the cases flocks are formed by OH minus, hence pH value decreases. Alumina or aluminium sulfate Al2SO4.18H2O, copras or ferrous sulfate FeSO4.7H2O, copras plus lime, calcium oxide, copras plus chlorine Cl2. Filtration. Process of purifying water by passing through bed of sand or other fine granular material. It should be free from clay, loam, lime, and organic matter. It should not lose weight more than 5% when placed in hydrochloric acid for 24 hours. Pre-treatment coagulation not required. Atmospheric pressure is enough in slow sand filter, whereas in rapid coagulation is must force more than atmospheric pressure. Construction skilled supervision simple not required for slow sand filter, whereas for rapid complicated and under drainage is property of the design essential skilled supervision. Economy high initial cost and low maintenance cost for slow sand, whereas low initial and high maintenance cost. It is cheaper and economical for rapid sand filter. Economy done. Suitability, small village and individual industry slow sand filters may be used. Universally adopted almost all major cities and towns rapid sand filter. Enclosure tank depth 2.5 to 3.5 meter. Plan area 100 to 2000 meter square. Number of units. But in rapid sand filter 2.5 to 3.5 depth, plan area is 10 to 50 meter square. Number of units is given by 1.22 under root q, where q is the plant capacity in million liters per day. In million liters per day. Base material size of gravel greater than 3 mm to 6.65 mm, and whereas in rapid is 3 mm to 40 mm. Depth of bed layer by 150 mm, 300 mm to 750 mm. Rapid sand filter 600 mm to 900 mm. Filter sand size of sand uniform layer 0.2 to 3.5 mm. Smaller grain at bottom 3.35 to 0.55 mm. Depth of bed 600 to 900 mm, whereas in rapid sand it's 1100 mm depth of bed. Uniformity coefficient Cu is 2 to 3, whereas in rapid sand it is 1.2 to 8. Rate of filtration 100 to 200 liters per hour per meter square, but in rapid sand filter it's 3000 to 6000 liters per hour per meter square. Remove turbidity up to 50 parts per million, whereas in rapid sand it's 40 parts per million. Efficiency bacteria removal up to 99%. Less efficiency in if color present in water. Whereas in a rapid sand filter bacteria removal is 80 to 90%. Very efficient in color removal. Period of cleaning is 1 to 3 months, whereas that of rapid sand filter is 1 to 3 days. Under drainage system led in order to receive filtered water in slow sand, whereas led to receive under drainage system is led to receive the filtered water and also to pass water for backwashing and at very high rate. Now pressure filter, these are just like small rapid sand filter placed in closed steel vessels, cylindrical in shape. Water is forced into filter by pressure. Rate of filtration is 6000 to 15,000 liter per hour per meter square, hence less efficient than low and rapid sand filter in removing bacteria and turbidity. They are best suited for swimming pools, railway station, etc. That is other than drinking and municipal water usage. Definition: disinfection, the process of killing pathogenic bacteria from water and making it safe for public use, that is no infection, is a disinfection process. Most commonly used disinfectant are for drinking water through the world is chlorine. The process of applying chlorine compounds in a small quantity to water to disinfect is known as chlorination. Note: sterilization is removal of all bacteria, that is pathogenic and non-pathogenic. Some minor methods of disinfection other than chlorination are boiling of water. Most bacteria is destroyed at a temperature of 80 degrees centigrade. In case of large scale, it's impracticable to boil water. Excess of lime treatment. Generally, lime is used for softening, but excess of lime may kill bacteria also. But it also increases pH value of water. Main disadvantage makes it basic due to lime. Bromine. The process, it possesses less eye irritation than residual chlorine, hence largely used as disinfectants in swimming pool. Ozone. 3O2 under high electric arc voltage forms 2O3. O3 disintegrates to or decomposes to O2 and nascent oxygen. Advantage: nascent oxygen produces a powerful is powerful to remove organic matter as well as bacteria from water. Ozone is unsuitable, nothing remains in water by the time it reaches the distribution system. Disadvantage: it also removes color, taste, and odor of water. Its Its tastes become bitter to tongue when ozone is used. Moreover, it is costly. Now, chlorination in detail. In fact, direct chlorination (Cl2) kills bacteria when pH is less than 5, although other compounds made of chlorine, called chlorine compounds, are more efficient than direct chlorine. Various forms of chlorine can be applied in the form of chlorine dioxide (ClO2). It is powdered 2 to 2.5 times stronger than chlorine but is very useful and costly. It forms hypochlorites or bleaching powder. In bleaching, chlorine content is 30 to 35. CaOCl2 water reagent Ca2 plus twice OCl minus plus H plus when pH is less than 7 and pH is greater than 8 forms HOCl. Hypochlorination is less efficient than chlorine. In the form of chlorine with ammonia, Cl2 plus water, pH is greater than 5, HCl plus HOCl, hypochlorous acid. HOCl, pH is greater than 8, pH is less than 7, H plus plus OCl minus, hypochlorite ions. So chlorine only available in the form of hypochlorous acid HOCl, hypochlorite ions OCl minus, and molecular chlorine existing in sample of water. Hence, hypochlorous acid plus hypochlorine ions plus molecular chlorine equals free available chlorine. Although hypochlorous acid HOCl is most predominant, that is 80%, than other two, hence maintain pH value less than 7, while chlorination, moreover, HOCl is immediately reacts with ammonia present in water and forms chloramines more predominant than HOCl. NH3 plus HOCl in um, medium pH is greater than 7.5 gives water and NH2Cl monochloramine. NH2Cl plus HOCl pH 5 to 6.5 gives water and NHCl2 dichloramine. NHCl2 plus HOCl pH less than 4 water plus NHCl NCl3 nitrochloramine. Depending upon the pH value, these chloramines kills bacteria more efficiently. That is, we maintain pH less than 7, hence NaCl2 is highly formed. To get efficient results, add enough additional ammonia to water. In case of less ammonia, treatment will chloramines is less irritation to nose and eyes, hence pathogens killers are NH2Cl is greater than NHCl is greater than NCl3 is greater than HOCl is greater than OCl minus is greater than Cl2. Time of contact of chlorination greater than 20 to 30 minutes, that is time from addition adding chlorine start killing. Contact period is directly proportional to 1 upon temperature. Types of chlorination. Plain chlorination. Chlorine is added to plain or raw water in tanks and reservoirs. It indicates only chlorine treatment. No other treatment has been given. Amount of chlorine required is 0.5 parts per million. Pre-chlorination. Chlorination is added to raw water before sedimentation. It reduces bacterial load on filters, thereby increasing their efficiency. The normal dose are 5 to 10 milligram per liter, so that it at least zero point 0.2 to zero point 0.5 parts per million is residual chlorine comes to filter plant. Post chlorination. Chlorine is added after filtration. It is also known as disinfection. The amount of chlorine added should be such that a residual chlorine is about zero point 0.2 parts per million appears in water after a contact period of 20 minutes. Double chlorination. Chlorine is added twice, generally pre and post chlorination. If pre-chlorination done simultaneously, double chlorination happens. Now, breakpoint chlorination. Curve AB. By addition of chlorine from A to B, chloramines are formed, although some of the chlorine molecule consumed by killing bacteria. Hence, AB curve slightly less than imaginary curve ish. Now curve BC. From B, chlorines starts killing bacteria more rapidly. From B to C, the applies chlorine may also participate in oxidation, killing bacteria. At C breakpoint, the oxidation is finished. That is, there is no bacteria. Therefore, residual chlorine will reappear. Straight line CD. After breakpoint, there is no bacteria. Hence, further addition of chlorine will appear equally as pre-chlorine. The phenomena of AC is called breakpoint chlorination. Residual chlorine milligram per liter and applied chlorine milligram per liter. The imaginary line will appear when there is no chlorine Cl2 consumption, that is for pure water. Any addition of chlorine Cl2 appearing equally as free residual Cl2. Breaking point. A, B, C, D, 45-degree, clear. Straight line CD. The phenomena after breakpoint C, there is no bacteria, hence further addition of chlorine molecule will equally appear as free chlorine. The phenomena from A to C is called breakpoint chlorination, post chlorination. The phenomena after C is called superchlorination. Superchlorination. A high dose chlorine, that is 2 to 3 parts per million, is added to water beyond breakpoint so that required residue will left. If not stabilized, may add chlorine after breakpoint. This may be done in some special case like highly polluted water during epidemic of waterborne disease. Dechlorination, the removal of unwanted excess chlorine in water by chemical or physical. Simple aeration treatment is known as dechlorination. Most commonly, dechlorinating agent activated carbon, ammonia NH4OH, sulfur dioxide gas SO2, sodium sulfate Na2SO3, sodium bisulfonate bisulfate Na2HSO3, Na2HSO3. Now sodium meta bio bisulfate, sodium meta bisulfate Na2S2O5, sodium thiosulfate Na2S2O3, cheapest agent. Testing of chlorine residual, chloro test, DPD test, ortho iodine test, starch iodine test. Hardness of water, hard. Water is are undesirable because they may lead to soap consumption, feeling rough while bathing, making food taste, tasteless, causing corrosion by water and tear by wear and tear, causing corrosion by wear and tear, friction losses in pipe, etc. Underground water are generally harder than surface water. Hardness of water can be measured by EDTA method, temporary hardness, due to the presence of calcium and magnesium carbonates or bicarbonates, calcium carbonate CaCO3 precipitate, calcium bicarbonate CaHCO3 whole 2, magnesium carbonate MgCO3, magnesium bicarbonate MgHCO3 whole 2, permanent hardness due to the presence of calcium and magnesium sulfates and chlorides or nitrates, that is calcium SO4 minus NO3 minus Cl2 minus and magnesium SO4 NO3 Cl2. Softening of water, reduction or removal of hardness of water is softening. Removal of temporary hardness by sedimentation, by forming insoluble precipitates. CaCO3 is insoluble precipitate, can be sedimented. Boiling, only CaHCO3 can be affected. Since magnesium carbonate or magnesium bicarbonate is soluble in water, calcium bicarbonate CaHCO3 whole 2 heat it decomposes to calcium carbonate insoluble precipitate plus carbon dioxide releases and water. Addition of lime magnesium carbonate plus CaOH whole 2 and gives magnesium hydroxide insoluble precipitate plus calcium carbonate precipitate. Magnesium bicarbonate MgHCO3 whole 2 plus calcium hydroxide gives calcium bicarbonate plus magnesium hydroxide precipitate. Calcium CaHCO3, calcium bicarbonate plus calcium hydroxide gives twice CaCO3 plus 2 times water. 2. Water molecule. Temporary hardness, also known as carbonate hardness. Carbonate hardness equals total hardness or alkalinity, whichever is less. Removal of permanent hardness by lime soda process. Lime CaOH whole 2 plus soda Na2CO3 lime. Although magnesium reacts with lime and calcium reacts with soda, magnesium sulfate or nitrate or chlorine plus CaOH whole 2 gives calcium sulfate or nitrate or chloride plus magnesium hydroxide precipitate. Calcium sulfate, calcium nitrate, calcium chloride plus Na2CO3 gives calcium carbonate plus Na2SO4 or sodium nitrate or sodium chloride as precipitate. Zeolite or base exchange or cation exchange process. In this process, hardness of the water is passed through bed of zeolite, sand, Na2 While passing the cation, calcium, magnesium can be replaced by sodium Na2 plus, that is, cation are exchanged. Calcium magnesium sulfate NO3 Cl2 plus Na2Z gives calcium magnesium Z rest in bed plus Na2 sulfate nitrate chloride precipitate. After softening of water zeolite bed loses the zeolites Na2Z, hence these can be charged by passing sodium chloride NaCl. Charging of zeolites, calcium zeolite, magnesium zeolite plus twice NaCl gives Na2Z plus calcium or magnesium chloride as precipitate. It is observed that calcium and magnesium chloride are not in water, hence easily separated manually. The rate of filtration is about 18,000 liter per hour per meter square. Zeolite process. Process is costlier. Lime soda process is economical. Mm, Zeolite compact and small, whereas lime soda bulky and large. Zeolite, no sludge is formed. Lime soda, large quantity of sludge is formed. pH value not affected. Lime soda, large quantity of sludge is formed. pH value not affected. Lime soda process increases pH value, uh, can economically treat excessively hard water, can be treated by lime soda process. Hardness is less than 800 milligram per liter, whereas in lime soda hardness is greater than 50 milligram per liter. Water distribution system, dead end system or tree system, grid iron system, city or town rurals having rectangular pattern improvement over dead end system, ring system unplanned city only, radial system opposite to ring system, sanitary engineering combined sewage, surface and storm, and sewage water infiltration, water leaks from ground to sewers, exfiltration, water leaks from sewers to ground, design of sewers, internal diameter is not less than 15 centimeter, self-cleansing velocity not less than 0.75 meter per second, land disposal and sewage required large area of sandy and alluvial soil, sewage treatment, primary treatment, screening, grit chamber, sedimentation, coagulation, secondary treatment or biological treatment of sewage is done by sewage filters and activated sludge process unit. Mostly used filters are trickling filters. And with this, we conclude our course. Hope you like it. Do visit again.